Let's look at a couple more examples of root equations. Here we have the cube root of x plus 4 is equal to negative 2. So maybe just a reminder of what the cube root means. I'll first look at the square root. So the square root of 16 is equal to 4. And often in the square root, you can write a 2 here to indicate you're talking about the square root. So the reason the square root of 16 is 4 is because if you square the 4, it takes you back to 16. So likewise, if you look at a cube root of a number, like let's say the cube root of 8, well, it turns out that's going to be equal to 2. And the reason for it is if you take 2 and now you were to cube it instead of squaring it, 2 times 2 times 2 is equal to 8. So if like the square root takes you in one direction, squaring takes you in the opposite direction. We would say that these are inverses of each other. So the same thing happens for the cube root. If you cube root 8, you get 2, and then cubing 2 takes you back to 8. What this tells us is, if we have an equation with a cube root in it, and you want to get rid of the cube root, we're going to cube both sides instead of squaring both sides. So we have the cube root of x plus 4 is equal to negative 2. To undo a cube root, we don't square, but we cube both sides. So I've done the same thing to both sides. On the left side, cubing a cube root leaves you with just the thing underneath the root symbol, which is just x plus 4. And on the other side, if you were to cube negative 2, well, it's going to be negative, and 2 times 2 times 2 is 8. So the root symbol is gone. To solve for x, we can subtract 4 from both sides, and we have our answer. I think it's worthwhile to plug this in to check to see that it's true. So just to check our work here, if I take my equation and I put negative 12 in place of x, does it equal negative 2? The cube root of, let's see, negative 12 plus 4 is negative 8. And this time, if you cube root a negative number, that's completely okay. A cube root can take on negative values where a square root can't. We get negative 2 is equal to negative 2, and it's in fact a true statement. So negative 12 is a solution to the original equation. There are a couple of different notations when talking about like square roots or cube roots, or any number root, so n could be 2 or 3 or 4. Instead of using this root symbol, you can write it as x to the power of 1 over n. So just to look at that a little bit more carefully. If you have the square root of x, really we're talking about this root, we can write this as x to the 1/2 power. So essentially I'm saying these two things are equivalent. So to maybe justify why this is true, if you square both sides of the square root of x and x to the 1/2, we know that on the left, squaring a square root leaves us with just x. And on the right side, if you have a power here and a power here, there's a rule that says you can multiply these two exponents together. And 1/2 times 2 is simply 1. We don't really write the 1 if we don't need to, and so we get x is equal to x. So this notation of writing a 1/2 power is just another way to express this type of a root equation. So maybe just as another example would be a cube root. This is going to be x to the power of 1/3. And you can keep going. If it was a 4th root, the power is 1/4. Let's use this new notation to solve the equation x plus 5 to the 1/2 power plus 1 is equal to x. I know this means a root. So to solve this equation, I want to get this piece by itself. I'm going to subtract 1 from both sides to do that. My equation becomes x plus 5 to the 1/2 power is equal to x minus 1. So the next step is to get rid of that 1/2 power. And if I put a 2 right next to this 1/2, it'll cancel it. That's saying I'm squaring both sides. So if I square the left and I square the right, let me just copy those sides down. So I'm just using a bracket and a parenthesis because I have like two different symbols happening at once, but really what this means is I'm squaring both sides. On the left, I have 1/2 times 2, and that multiplies to just 1. So that's really x plus 5 to the first power. And on the right, I have x minus 1 squared. So on the left, I don't need that exponent of 1 or the parentheses. It left me with just x plus 5. Now on the right, again, I gotta be careful here. I have x minus 1 squared, which means x minus 1 times x minus 1. That's x squared minus x plus 1. That is, x gets multiplied to x gets multiplied to -1. That's where the first two terms come from. And I do the same thing with this -1. I get a negative x, but then a plus 1. So this whole thing simplifies to x squared minus 2x plus 1. So just, again, being careful where, okay, I see I'm squaring this thing. It really should be equal to x squared minus 2x plus 1. So to solve this equation, it's a quadratic. I think I'm going to set one side equal to 0, meaning I'll subtract x and 5 from both sides. I have 0 is equal to x squared minus 3x minus 4. Okay, so I could like use the quadratic formula, but I think this one should factor. We get x minus 4 and x plus 1. Looks like there's two solutions. If I put 4 here, that makes this factor 0. If I put -1 here, my other factor is 0. So those would be x is equal to 4 and x is equal to -1. I just want to check to see if one of those is an extraneous solution or not. So let's start with this x is equal to 4. I'm going to take that and plug it into this equation. So we get 4 plus 5 to the 1/2 plus 1, is that equal to 4? That's 9 to the 1/2 plus 1 is 4. 9 to the 1/2 is the square root of 9, which is 3. Oh, right, 4 is equal to 4. Well, that's true, so it's good. Okay, let's now try -1. In this equation, I get 4 to the 1/2. This is not looking good. 4 to the 1/2 is the square root of 4, which is 2. And 3 equals -1. Okay, that's false. And this means that was extraneous. There's only one solution to this equation, and that is x is equal to 4.